Okay. All right, we're live finally. Sorry for the delay, everyone. If there are people online, today is Wednesday, February 6th, 2019, and this is the Atlanta FileMaker Developers Group. Let's go around the room and start with our introductions. And you can first.
I'm Jesse Barnum. I'm with 360 Works.
I'm Darcy Holdorf. I work at the Folk School, the Johnson Campbell Folk School in Brasstown, North Carolina.
I'm Junior, 360 Works.
I'm Sean. I work at 360 Works.
Nick, I work at 360 Works over just a month ago.
Earl Cook, Laser Solutions.
Gail Cook, Laser Solutions.
Christy McAdvantage.
Oops, and and I'm David Naeda from Blue Feather. And our presenter for today is Vincenzo Menanno. Did I pronounce that correctly?
That's correct, yeah.
All right, from Beezwax, and he's going to be presenting today on optimistic versus pessimistic record locking in FileMaker. Vincenzo, I'm gonna make you the presenter here, so everyone's seeing your screen now, and and everyone can hear you, and we'll be probably asking questions during your presentation as well. So.
Okay. Yeah. It's a little bit hard to hear some of the people in the room, maybe because they're further away from the microphone, but I think we can work with it. Cool. Thank you for inviting me, so thank you for having me have the opportunity to present remotely as well. So this presentation is a talk that I have given in Europe at some of the European conferences, in the French European FileMaker conference in La Rochelle, and then I gave the same talk in Bologna in Italy, and then the same one in UK. And this last year, I had the opportunity to go to Japan for my first time. So I actually presented this in a translated version that Shin translated into Japanese, which was a lot of fun. And I got to go visit Tokyo for the first time. That was great.
Cool.
Okay, so kind of start off with a question and a statement. What if you could dramatically reduce network traffic? And one example, we reduced network traffic by 97%. Reducing network traffic translates into less stuff for the server to do, less network traffic on your network. Obviously, sending only the field changes and not the entire record is something that we've always, or a lot of us, have been wanting to do. So there's opportunities for that in some cases, and also reduces the amount of record locking that the server needs to manage when people hold on to record locks, etc. So there's a lot of benefits to doing something like this, and this translates into potentially huge savings if you're using AWS and you're paying for network traffic that goes back and forth. You can improve overall solution and performance. And one example, we've proven to improve performance by 93% faster. Improved performance translates into less data to send to users. Performing data manipulations transactionally enables stored values, and with stored values then also enables you to have less network traffic and faster rendering of data. So overall, things are faster, basically. And in our case, because we run all the transactions in one place, we also use that particular moment to do the auditing. So in some cases, the clients that we work for want to have some auditing, and so we do that. And just to be clear, the auditing that we're doing is all the fields in the table. We're only the clients are only interested in particular fields 2 or 3 fields that are kind of critical, that hold critical information. And so they want to just make sure that they know who changed those values and when they got changed. I'm from Beezwax. I'm director of FileMaker development here, certified in all the versions till the present version. Author of Inspector Pro. These are my kids. Some of the things I've done. A lot of you may have or have followed some of the blog posts that we post on our blog. I've been doing a lot with Perform Script on Server. We have a lot of blogs about that. We have some great blogs that are listed here, blog posts. There's a great blog post that Will Baker did about master detail when that became available. There's some great examples what's possible with that. If any of your clients do any work with Excel documents and they import data from Excel, there's a great technique to shuffle the importing or move the importing to run on the server. So using PSOS and a special way to set up some of the directories on the server so that you can move the Excel document to the server and then run the importing of that on the server. We've been getting into Tableau more and more. And so a number of the clients that we work with are looking to build dashboards in Tableau. So there's some blog posts about Tableau and how to do integrations with Tableau. And there's some really exciting things that are possible with embedded dashboards back into FileMaker with Tableau and using FMP URL to interact with the underlying data. So definitely check that out if you're into Tableau. Debugging web viewers, there's a blog post that Simon put up. If you do anything with JavaScript and web viewers, you definitely need that tool. And then a few months ago, one of our interns got Apple Maps working. So if you're interested in using Apple Maps rather than Google Maps, you could check that out. And FMAJAX is also there. Anyway, I mention all these because oftentimes some people know about them, some people don't know about them, but there's a lot of good material there, so definitely worth checking out. Okay, I had this. These are slides that are kind of repurposed from my tour in Europe. Anyway, I think 360 also hired a couple of interns. I'm not sure, and I'm not sure if one of the interns is actually in the room there tonight. But yes.
Yes.
Oh, cool! Awesome. We are really, really proud and excited about this program that FileMaker has officially partnered with 42 to provide internships. And Olivier De Vries from Listerius, French platinum company in Paris. He let me know that the program has officially launched in Paris now too. So that's very exciting. So anyway, we've gone through 3 rounds. We've pretty much hired every single intern that we've interned with. Almost every intern. One ended up taking a job elsewhere afterwards, but they're really great, and we really love working with them, and I hope the program continues and expands. So for all of you in the room, if you hear about this program, I would highly encourage you to look into more about it, because although the interns are interning in what is it, Fremont, I guess, here in the Bay Area, they're potentially able to travel to different locations. So a great opportunity, especially as the platform goes into new areas and new territory like JSON and curl and JavaScript and stuff like that. These interns are more than capable to dive into those new technologies as well. So definitely worth checking out. So one of the things, a few of the things that kind of covered by this talk is some of the security concerns that have been brought up, performance, implications or changes that can come about by using optimistic record locking, and control and more of a warning or responsibility. You have to know what you're doing if you go down this route. Otherwise, you can get yourself in a tight corner. So the way I've gone about talking about this is kind of through the evolution that we've taken. So like we talk about native editing, and you guys all know what that is, basically the native behavior of FileMaker. We talk about how we started down this road, which was we started doing global edits, which I'll describe when I get to it. Then we went to local edits. Now we're kind of using a combination of local edits and data API. And we talked about the benefits and drawbacks of all those. One of the things I like to do with kind of like any system that I kind of get my hands on and try this out is I like to do what is called a commit footprint. And what I like to do is I like to time the amount of time it actually takes the server to make a change to a record, thus opening the record, making the change to the record, and committing the record. And so we have an inner measurement and an outer measurement. And the outer measurement here can be measured in different ways by the start of the script, the end of the script. The more critical one is the inner measurement. And what we do is we're just curious to see how much time it takes if you're on a LAN, if you're, I mean, mostly if you're on a WAN, and how much time it takes for you to perform that same action, and if you were to transfer that action to the server. So like if you run it locally, meaning not locally on a LAN, meaning like if you run a change to a record and you're on a wide area network, the inner time and the outer time in this case, for this example, was about a second and a little bit less than a second. So the whole script took about a second to execute, and the inner part where it's actually just timing the opening of the record, the changes to one data point, and then committing the record, that took almost 3/4 of a second. If you transfer that process to run on the server, the numbers are very dramatically different. So like it takes a fraction of a second, a few milliseconds to actually commit the record. So if you can scuttle the data over, then the server is very, very efficient at making the change, committing the data, and being done. Whereas on the client, you're having all the overhead of the whole record moving up to the server, the commit happening, and then completion of that process. So almost a second to a very finite, smaller amount. And so with this information, kind of armed with this information, we embarked upon trying to move everything to get transacted on the server. And so when you do start relying on perform script on server more and more, you have a lot of things to consider. So the benefits are really huge for WAN-based solutions. You got to take special care when relying on PSOS. You got to pay attention to a lot of details. You got to have there's a whole slew of things that you need to be aware of, and things that can kind of trip you up, like on open, you set a bunch of globals. However, you might not have those globals set on the server when the script runs there. Plus, you have all the triggers that run every time you fire PSOS, all the on open, first window open, on window open, on last window close, and on window close triggers. If you have any scripts attached to those will fire as well. And so you might want to take special consideration when coding to maybe not have those run when you're running PSOS. So you want to reduce the overhead. Another thing that we do, we keep a PSOS log, meaning that every time we run a PSOS script, we'll also keep a log of how many are running at the start of that process and how many are running at the end. And so we can see if any of these scripts are kind of stacking up against one another. The worst case is if you end up architecting this whole solution to be so heavily dependent on PSOS that some of the scripts take a longer period of time to run, and then you have a lot of users and a lot of users are running those scripts. You could get yourself in a bind where the scripts are stacking up and now performance is not actually degrading for diminishing for users that are connected because those scripts are all concurrently running and they're taking longer to execute than they would normally. So we keep a log, and every time we depend on something else that we want to run on the server, we also look at how long it's going to take to actually execute on the server. So that we monitor that very closely at the beginning and during, and from time to time when a system is in production. You can also do some creative things with building in support for immediate and deferred. Immediate is I edit a record and I want to see the changes right away, or deferred is I want to send it into a queue and there's some recurring script that is just picking up the tasks to process, and it doesn't matter that they get done at a later time. And so you can also use reduce the amount of PSOS dependencies to put it in a deferred queue rather than also having everything to go through like immediately. So so users can just put a record in a table, and then one scheduled script can just cycle through there and process those when it needs to. So that way you're not tying up another PSOS session with those requests. So some creative uses there. Any questions so far before I dive into this other stuff? Nope. Okay. So native editing benefits are, it's a pessimistic record locking model. That's what FileMaker is inherently. And, no, there's no extra work on your part. So like as soon as you start typing in a field, then the act of making a change to a field gives you a lock to that record unless someone else has locked it. And if someone else has locked it, then you'll get a message from FileMaker saying, you can't change this record because someone else has a lock on it. So once you have a lock on the record, no one else can make changes to it, which that's a good thing. I mean, that way you're guaranteed that your edits get in and no one else can, put any edits in there while you're doing that. The drawbacks are, over time, not over time, but it depends on the complexity of the solution. What ends up happening is, for the first part, just mentioned first is what I was mentioning before, is if you're on a wide area network, it takes more time for the record to be scuttled back and forth and for the commit to happen. If it commits on the server, it happens very quickly. So overall performance is going to be slower depending on your speed, etc. So it's a little bit less performant that way. There's, I like to refer to what ends up happening once you end up with calculations that are, related to related data, and they're unstored calcs. Those calcs then have to be unstored, and if you depend on other unstored calcs and you depend on those fields, you use those fields in other calculations, everything is unstored. Eventually, the system will be very, very slow. because it depends, again, it depends a lot on the complexity of the solution and you know, a number of factors. But once you have something that's unstored, everything downstream of that is also needing to be unstored. So there's some issues there. The first time we started doing this, we started it with popovers in global fields. So basically what the benefits of global edits would allow you to do is it gives you the opportunity to do optimistic record locking, which means that the record is not locked locally. You take the data from the record, you take whatever fields you want to modify into global fields, and allowing the user to make those changes. And then in that popover, you would then have a button that would say save or something, and it would you know, take that data, send it via PSOS along with the record ID of the record that you're on, and then the script on the server would find the record and make the edits and commit the record. So this gets you down the road of optimistic record locking. If you can store things transactionally, then in some cases, if you can guarantee that, then what ends up happening is you can improve performance down the road, because if everything is stored, then there's less work for the server to deliver data to the clients, because if they have unstored fields that relate, like if you have an unstored calc that counts the number of tasks on a project, the server has to send all the related records of all the tasks to get you to resolve that calculation. So the server has all this extra work to do to send that data down. And the other thing it kind of introduces is this opportunity that we've been looking for some time, is the ability to only send what's changed to the server. So that, like, in those 5 fields that I made changes, I could see which ones I actually changed, and then I could just send a JSON packet of just those ones, and then have the server make the edits to that record for just those items. And so it can be a lot more lightweight network traffic that is transferred. And it gives you the transactional control, and again, you can store the values. It also gives you the opportunity at that point to do auditing. So that's kind of cool. The drawbacks is this is more work to set up. And if you're in a LAN environment, it might not be worth the effort and the hassle, just because you might get very little, you know, additional benefits, speed benefits. So it might not be worth it. The other drawback we found over time is that globals can crosstalk. So we had some situations where some people would have a record in one window, and they would click a popover, and they would get these values from that record loaded into this global, but they would open up another record in another window. They'd click the same popover, and now they'd have globals filled in from the second record. But if they were to submit on the first record, that data from would come in from a different record. So that crosstalk was bad, and you can avoid it by making the mode you can make a card window modal, but then that forces users to this, I have to finish this edit before I can do anything else. And in some cases, the workflow for users was that they may need to actually look at and review data on different records as they're putting in some edits on another record, or they may need to start edits in different places and complete them when they're ready. So, and this also relies on PSOS. Again, not that PSOS is a bad thing, but you have to be careful how much stuff you put through there. So those are some of the drawbacks. Local edits is kind of cool, and this is some. Yeah, go ahead.
This is Jesse. Quick question. If the goal of it is to get your commits to happen on the server, would WebDirect be another way of doing the same thing?
Would WebDirect be another way? Yeah, I guess you could. I don't have a lot of experience with WebDirect. but yes, I believe so, because that all is all the scripts run on the server.
Okay, and I haven't
You
used
probably have more experience.
I don't use WebDirect myself that much, but I was wondering if there was pros or cons to WebDirect versus the idea of kind of using PSOS to trigger it to happen on the server.
I guess
Yeah.
memory load, because WebDirect is very memory intensive on the server. So if your server doesn't have a lot of RAM, it might not be able to support a lot of users.
So you have a lot of overhead besides just
Yeah.
the actual committed records.
And WebDirect's kind of slow, and there's a limit to some of the functions that you can do on there versus what you can do with a mix of that and with a mix of sending stuff to the server and FileMaker Pro, which can handle some other things.
Sorry, let's go ahead.
Oh, okay. Sorry. So I heard some of those comments were that it was very memory intensive. Is that correct?
Yeah,
WebDirect.
WebDirect.
So if you have a lot of users.
Yeah, with a lot of people, it can use a lot of RAM on the server. So on the host.
Okay. Yeah. I know Alina has had a project where she's been using WebDirect, and not that many users, but she feels that she just wishes she could just go and use native FileMaker for those users, because there's some idiosyncratic behavior with uploading attachments or downloading attachments, and the user experience is something you have to pay a little bit more closer attention to. And so anyway,
Okay.
so local edits is something kind of interesting and different. We started doing this, and we now have this in production in a couple of systems. And what local edits allow you to do is get around that global issue. But so some of the benefits are it also delivers optimistic record locking, improved performance, ability to only send changes, store values, all the things we just talked about before. Drawbacks is it's a little bit more work to set up, and maintaining a separate file, and I'll explain that in just a moment here. So what local edits is let's say, imagine, if you will, I have I actually probably should show it. It'd be easier. Let me see if I can skip over to here. Let's see there. Sorry. So so what local edits do? Can everybody see my screen?
Mhm.
Yeah.
Okay. Okay. So so I have a very simple example here that we're a concert tour company, and we set up tours for rock bands, and there's different tasks to set up. So these are tasks related to this tour, and so what we do is, when this file opens, we have a script that will extract a file that's embedded inside that file. So it gets this file, and it gets the path to the desktop if you're full access, and it gets a temporary path if you're not full access. And then what it does is it exports that file, and then it defines a variable, a global variable, and that global variable is used in an external data source as a variable file reference. And so what that gives us is the ability to do things like this. So like this window is a layout in that other file. and so that I could go in here and make a change to this tour, or I could go in and actually I have a record in that local file that represents this data for this record and all these tasks that are related to this record, all recreated in the local file. So what that does, let me go back 1 second to the way it was, because I think the card window isn't resizing. So what that gives us is the ability to have some situation like this, right? So the problem I had before, where I may have 2 different windows because I'm booking flights and setting up venues and things like that. So I can edit the Emerson, Lake and Palmer tour in this window, and I can edit the Elvis Costello tour in this window. And these are attached to the window, right? So these are things that are going on independently. So I noticed I might have broken something in here. I don't know what happened, but we've been making some changes, so I apologize if there's something broken in there. But the idea is that it works from the point of view of attaching itself to the window. And so now I have a record in this local file that represents this edit with all its associated related records. And what's cool about this is in here, I can make any changes I want until I'm done. And I can actually, in fact, have a very complex set of calculations that are all unstored, or summary values that give me like all kinds of information, and all those changes, clicking in and out of the fields, all that is happening locally. None of it is happening on the server. And so when I'm ready, I can press a button and save those changes, and then submit them to the server. And it would then take all this data, pack it up as JSON, send it to the server, and then it would find the record, make the changes, and commit those changes. So this gets us off this kind of solves the problem of having the edits crosstalk, because you're putting those values in global fields.
How does that local file?
Go ahead. Question?
Yeah, does the local file?
As a local file?
Are you picturing that this would be, you would be working as a guest of the server in list view, and when you click on a particular record, then you copy those record contents to your local file and edit it there? So the local file would basically be like a little temporary cache of a single record?
Yeah. Yes, correct. And so this is so basically on open of this file, we basically go to a layout that has the local file embedded in a container, and we export it locally, and go ahead.
Well, my question wasn't so much where does the file come from. My question was more, at what point does record data get put into that file?
As soon as I click this button, the data that's in this record gets moved to the local file, and then it gets opened up in a card window.
When you click the edit button?
Yeah. Okay. And then so when I cancel, this is an early prototype and stuff, and we don't have all the cleanups code that we have in the production system. So what happens is, if I delete all the records in here, okay, so all my records are gone. I edit this record. Now there's my data for that record. I go edit this record. Now there's my data for this record. There's a little bit of a problem with the portal data, but that's a bug that we have. That, but the point is that if you look at the 2 records, I started an edit for this one. I started an edit for that one. I would have both of those records locally, and then when I'm done on saving that data, so like on saving this data, we would package this up and then send it to the server, and then remove this cached record. And now every time we make a change, we always never keep this file. So I mean, we never keep this record locally.
For the local,
it's just temporarily for editing.
the local file will have as many records as the number of edits you're doing?
No, only temporarily. So that, again, this you have to imagine that when I click here, I load the data. When I click save, I take what changes I made, I send them, and then I remove the record. So in theory, the only records that exist locally are the ones that are being edited at the time that are being edited. Once you've saved it or canceled, those records are removed. In this case, I don't have that showing here, but that's what we do.
Okay.
Does that make sense?
Yeah.
Okay, so let's move on. This local edits. Let me just move to the next slide. Where was it? This one. Global edits, local edits. Okay, so then what came along is this big discovery aha moment for us, which was we discovered that the data API is actually indeed transactional, just like FileMaker is transactional, but the data API is transactional. And this is a really big deal. So, what we're doing now is we're still using the local file, and we get all the same benefits we're talking about before. Lightweight sending of the only the changes, etc. But now what we do is we send the data via the data API. We don't send it as a JSON object to FileMaker in a script, and then the script finds the record and makes the change. So we're basically pushing all the changes in as one transaction via the data API. And if that transaction is successful, then we do some other cleanup work where we audit what was changed, and etc. So the drawbacks are it's actually less work to set up because the other stuff had more code to write to get it to work. And so the skills needed here are you have to understand how to work with the data API, and it relies more on the data API. I will say this, that when you send it, it's still you got this. Some people would complain, well, why can't I just click in a field and make the change and then just hit enter? So yeah, I mean, the point that we make is we have better control. We can deliver a faster overall solution performance for the application down the road. If you're concerned about the overall performance of the solution for doing different other tasks. So they eat a little bit up front, where they have to load the data in the local record, and then they get a card window. I personally think that user experience is a nice user experience, and some people feel the same way. But some people who are used to FileMaker find it a little bit, kind of getting in the way. But anyway, it's a personal preference, I guess. We trigger some of we convert some of the calculations to happen by triggering them by this method, where we update, let's say, a timestamp, and that timestamp then once it gets modified can actually trigger the calculation to recalculate. There's a lot of considerations, and I probably won't have time to get into all those details about calculations, but that's a whole subject on its own. But this is one method that we've used to make sure that any record change, any data that we change in that record, we can also get the triggering of unstored calcs to move to stored calcs by this method. At least this is one of the techniques. Yeah, go ahead.
This is a couple more questions. This is Jesse. When you say that the data API is transactional, you mean like if you've got a portal, right? If you're editing portal records to the data API, or do you mean you can actually literally do multiple individual insert and update, patch and put operations transactionally?
No, like right now right now, portal data is anything you submit through there. And that, you know, in the past, the only way to achieve that would be to you know, have a looping script to make sure that you update all the related records before you commit, and then you could revert or whatnot. But in this case, you can send everything in one shot, and if any one of those related records is locked or validation fails on it or whatever, the whole thing gets reverted. Nothing goes in, so it's all or nothing.
Okay,
So
in this slide here, triggering calculations, this isn't going to work if task is a related table, right? It would only work if this calculation is in the same table as task.
if tasks is in a related table, again, the topic about calculations is much more in depth. So there's differences in terms of what calculations you use. So for example, for FileMaker, let's say that this aggregate calculation to count the number of tasks in the related table. So this, let's see, if there's a, how do I say this? Certain aggregate functions won't be counted with FileMaker aggregate functions. They won't be accurate because if it's a new record that's created in the task table, FileMaker will not know about it until it's actually been committed. And there's some subtle differences between the way that Data API works, and FileMaker natively works with aggregate functions, and I have to document those. But the one major difference is if you wanted to get an accurate count, you would use a SQL count, and that would account for the newly created record that's not committed yet in your transaction. But there's some performance concerns with that, and so that's probably not the best way to go. There's other ways. Go ahead.
Oh no, I didn't mean to get us off track.
What's that?
I was just saying I didn't mean to get us off track.
Oh, it's okay. Yeah, it's. I feel like there's a whole topic here that I need to get into a lot more. So I would like to maybe follow up on it, but I don't have answers for you right now. But there's other ways that. So, for example, there are other ways that we can keep or update data in other tables where you want them to be happening as part of the transaction, and they could be done through either updating records through the portal attached to that record, or we have other techniques whereby we go and update the record, that particular record, by sending a command to go and update that record. And because we don't allow users to modify any records, and that's all done transactionally on the server, and those commits happen very quickly, we have been testing this with a lot of users, and we haven't seen any locks where, you know, it's been locked by some other user, but that tried to try and update a record. And we have a technique where we will put ourselves in a little tiny loop, and we'll update a record. If it's locked by some other transaction, it will wait momentarily and try again, and it does that. It does that about 3 or 4 times, and if it's unsuccessful, it will create an error record or log, and alert us as to you know, it wasn't able to update that data transactionally. But when we hammered on it with a lot of people, we never got those error records to get logged. So the thing is that it really depends on how much transactional volume you have, and how complicated that commit footprint is for that record to get transacted. So again, a lot about calculations, and I'll have to follow up on that. There's a demo, kind of running out of time here, but let me just kind of give you a case study of a solution that we did some rework on. We took this one solution where they were complaining about performance all the time, and these are people that have a solution that is hosted in one place and users connect to it geographically from different regions all over the world. And one of the major things that we did was reduce the number of unstored calcs in the system, and we use this model that I'm discussing here, where we allow them to edit the data and then we submit the data and transact it on the server. The overall reduction in code was significant. The biggest deal was, just focusing on getting rid of unstored calcs. The improved performance was dramatic. People would open the file, it would be faster. They'd create a project in 2 seconds rather than 20 seconds. They get a project list a lot faster than they used to before. And again, all these numbers are for people that were on a WAN in different geographic locations. The admin view is the biggest deal. They had a bunch of portals in there, and all the data in all those portals was in an admin view, and every one of those portals had an unstored calc, and in an unstored calc, it took a long time to render all that data. And once we converted everything to stored values, it loads like almost immediately. So it was a big deal. We haven't gotten any complaints about performance since we put this in place. So go ahead.
I just said that's cool.
Yeah. And often in my talks, I always talk about this intersection of things. So what was a kind of a cool aha moment for us was that using card windows and using PSOS, it allowed us to enable this transactional approach to do things, and it gave us also this capability of auditing. Improving performance, we were also able to improve performance, but the big deal is that we started working with the data API more and more, and I think there's some exciting things coming for what we're exploring with the data API. So that gives us more of this opportunity to do this. Yeah. Okay. So let's see. What else do we have? Typical security. This is what it looks like. Oops, sorry. I'll go back there. So like you may have a mix and match of one user can view a record, they can create data, but they can't delete data. In one table, in another table, they can delete data, but they can't view it or whatever. So there's like a mix and match of privileges, and those are carved out by the business rules that you have to define for each privilege set, etc. In the changes that we made to security, basically they only have view access, and if they have view access, it might be in one table, it might be limited or restricted, but normally they have no edit, create, or delete capabilities. Now, I will say that the ability to do this then relies on the fact that the script runs full access on the server, so they can create data, they can edit data, they can delete data. And I presented this in Portland, and Matt had some reservations about security. You're opening up the script to run full access. He didn't think it was a good idea. In exploring this with the use of the data API, we found that I think we can roll back to the typical security model that people would have, and just not allow a user to actually edit a record on a layout, and so they wouldn't have any fields that would be enterable. The layout would not allow them to edit records, but their privilege would respect that. And so if we use the data API, then the data API would respect their permissions. And so if they had the ability to create data, then it would flow through. And so it would be mirroring exactly the permissions that they have. And thus we would not need to be opening up, scripts to run full access. So there's some considerations that we're reconsidering in terms of our approach there. Hope that makes sense. Okay, so I think there's just a few more slides, and then there's a couple of movies I have. I'm gonna actually skip this just because I don't have the time. Where is it? This is like actually, it's a funny example of the fact that actually I'll go ahead and show it. If you were to enter data in a portal for, let's say, for different fruits or vegetables, nutritional value or vitamin content or whatever, and how many of you allow creation of related records through a portal? Anybody?
Yeah.
Yes, definitely.
All the time.
Yeah. Okay. Well, if you do that and you're typing in that portal record, the parent record and the portal record are both locked, meaning that if you had 15 vitamin items to enter for strawberries, and someone was the different people on your team were different vitamin experts, they'd have to wait till all that data was entered by you to be able to then go in and put in their record. So adding rows through portals is going to lock the parent record and lock people out of also making edits to any related records until one of the users is done. However, if you do it with a transactional approach, and you have the ability to put in data through a popover or a card window, you can have a lot of data coming in on a particular item, and so much data that you can have actually 5,000 in this comparison, 5,000 more data entry points than you could in the other one if you were to look at it from a point of view of it taking that long to commit the data, and how many you can get in that time frame. In a second, you could add a lot more data. So that was just a kind of quick example. But let me show you. I have a couple of videos to show you, and then I have one wrap up, and then we're done. So let's see here. Movies. Let's see. Okay, so how many of you are familiar with this tool called Network Monitor? Have you seen that on the FileMaker community? If you do a search on the FileMaker community for a tool called Network Monitor, it lets you measure the amount of network traffic that goes to and from the client to the server and the server to the client on port 5003. So what I did is I just demonstrated how much traffic would be coming and going. And on this example, where I search for a record, and this field where it says completed, it's the number of tasks. And that field, there's no portal showing here. That field is just either, in one example, it's the stored field where we use our transactional approach, and then the other example is the unstored. So this is the unstored example. And if we're, oh, wow. Oh, sorry. Okay, sorry. Oh, that was some background noise there. Sorry about that. So what it did was I measured the network traffic for finding this record and the work that FileMaker had to do for sending the data down and any traffic that went out. So when the record was located, so 6,000 versus 6,101 bytes incoming and 414 bytes outgoing. Now I'll show the same test, okay? And this is using again this network monitor tool, And it's a little bit tedious to work with because you have to quit and clear the cache. And so what it does is it gets rid of those cache files that FileMaker uses, and then it relaunches itself. And now I'm basically launching the solution again to get in there. And what I'm going to do is I'm going to get it to a point where I'm ready to do the search. So I get into find mode, and now I'm ready to kind of go to the layout that doesn't have any, that's got the stored value. I start the test, and now search for the same band, and then stop the test. And when I stop it and view the log, what we'll see is, so here, now we have, for the stored value, okay, so the incoming amount of traffic is 222 bytes as compared to 6,101 bytes. And the outgoing traffic is also less. So, and the only difference between this example, where is it? This example, here, this one here, and the other one I just showed before is this field right here. This field in this test was a stored field that just had a static number, and the other one was an unstored calc. And when FileMaker finds that record and lands on that record, and it sees that unstored calc, it has this other work it has to do to say, oh, let me pull down all those related records, let me calculate this value and render it. And so that's what the end result here that you see. And so you have the unstored traffic and the stored traffic. I invite you to download the Network Monitor tool and try it out in all kinds of situations. I think you could definitely find things about your solution and maybe improve performance with it. Yeah.
Quick question. So the way you did that, was that by storing those otherwise unstored calc values before retrieving the record? Then? You triggered that in the server?
Yeah. So because we're doing it transactionally, those calculations are now stored. And so anytime I make a change to a task, if I add a task, if I remove a task, or complete a task, we're updating the parent record to make sure that the task, that constructor record is now updated transactionally as if it was part of the whole transaction. And so now when I go and I land on that constructor, rather than FileMaker having to do the extra work of pulling down those related records and calc that unstored calc for me, I'm actually taking the responsibility to make sure that that calculation is accurate at the time that it's being viewed. So, and accurate meaning that it's got to be accurate anytime a task is added, anytime a task is deleted, or anytime a task is edited. And so we guarantee that it happens transactionally, and if it doesn't, we notify the user that something went wrong, and they have to try again or contact us or something. So, does that make sense?
Yep.
And so I think that's it. The last slide I had was just kind of like a recap. Let me see. This guy here. So we kind of looked at optimistic versus pessimistic. I mean, FileMaker is natively pessimistic in the way it locks records. And if you opt to do it intentionally in a pessimistic model, you have to know what you're embarking upon. And so you have a lot of considerations. There's things that you need to do to get calculations to resolve correctly. And so there's that responsibility that you have to take into your logic and scripting. And you know, and in some cases, if you're relying on PSOS, there's also a lot to consider there too. So I would say mostly from my experience that things on a LAN, you probably, unless you really need to, or unless you really want to, you know, you're not going to get much, you know, speed benefits that would be dramatic or, you know, worthwhile embarking upon all this. But if you've got systems where people need to log in from all over the world or in different geographic locations, you definitely want to start to consider something along parts of this or some of this or all of this, whatever you like. And I'm open to other questions, or I can try and follow up with details about calculations at a later point.
A question that I had, Vince, this is Jesse again, is that I never saw how you were actually doing the optimistic record locking. Like I didn't see, and I mean, I know you didn't actually do a demo for us, but how would you do the actual checking of the version to make sure that the record had not been edited by somebody else? Would you look at like the get modification count function, or would you send up the previous values and compare them?
Yeah. So that's a great question, and what we do in the case where so first off, I'll answer one thing. Get modification count is pretty useless, because get modification count is going to give you all the times that the record has been modified. And in my opinion, if someone modifies the scheduled dates and someone else modifies the contract dates, I could care less that someone else made a change, but I made a change somewhere else on the record, let's say, And so modification count for me is not something I would bother with, but the way we get around that is what we've done is we generate a hash, and there's got the three-way hash. What is the state of the record, or stated more specifically, what is the state of the fields that I'm interested in at the time that I went in to modify the record? Now I've modified, the fields that I'm concerned about. Let's say the contract dates. I go in and I modify those contract dates. Have I made any changes to those dates since I brought it into to the local file? If I've not, then I just cancel out, and I just I haven't made any changes. The other thing is, just before you send it, you can also check if the hash of the state of the record that exists on the server at this present moment. And so if that state is different, then you can alert the user, someone else has changed the the schedule, the contract dates. Would you like to review those? Would you like to submit your changes? I mean, then you can apply whatever business rules your client would feel more comfortable with. So there is a way to trap for that, and in the situations that we've had to work with, then the client has not been interested or bothered with that. They just wanted to know who changed it and when it changed. So if someone went in there and changed an amount, and someone else went in and changed the amount again, they just wanted the audit trail to be there so they could see who changed it. They weren't so concerned that someone else had changed the record. They just wanted the audit history to reflect when and what changed.
So,
Yep.
in cases the last right wins is acceptable, is what you're saying?
Yeah, in this case, yes.
Okay.
And what else did you have? Like, oh yeah, so I mean basically, let's see if I have it here. Let's see. It's usually, I don't have a, is this is the one here. This has been changing or evolving because we've been doing it a little bit differently with the data API. So this is, I'd have to send you an example of how we do it. But basically, the data API is changing our approach. What we were doing before is we would do a pair of scripts, which is a local, like a script, and then a script that runs on server. And the local script would do the validation to make sure, I mean, in this case, if you wanted to do like the hash checking, etc. Plus it could do some validation to make sure that, you know, you filled in everything you had to fill in and you haven't left anything blank. And then it calls the script on the server, and the script on the server would then, you know, find the record, edit the record, and make the changes, and then commit it. And then if it wasn't able to edit the record, then it would report back to the user that, you know, the record was locked. But again, the fact that, you know, I go back to one of the early slides here, the fact that, you know, where was it? The time it takes to, you know, to commit the transact the record on the server is so fast. You know, you'd really hit collisions only if there was a lot of activity on a particular record that everybody had to touch. So it depends on, you know, the application itself. In some cases, different managers are responsible for different gigs, let's say. So they're the ones managing those gigs. There's never really a collision there, you know. And then if there are, for updating the parent record, those things, again, in that small iterative loop, they get resolved very, very quickly, and then that transaction flies in as well. So, yeah.
Okay, thanks.
Yeah.
So I'm open to more questions if anybody has more questions.
Vince, I was wondering, this is Junior from 360 Works. How long has local editing been around? I'm kind of new to FileMaker, and this is the first I've seen something resembling this.
Let's see. In our company, we've been using it for about I'd say almost about a year, a little less than a year. So we started exploring how to get around the issue with global editing, and then we came across this idea of like using a local file. I can tell you this: there's one group that we work for where the editing of a particular task is related to a lot of financial calculations that come from a group of records where they need to run some numbers and total up some totals and do the math on all those records, and all that would have been all unstored and very, you know, very messy to get done. And then what they do is they save it, and then basically it renders it as a JSON object and goes to the server and transacts it on all the records it needs to transact it on. And they had trouble doing that in different remote locations, and now when they run it, it takes like a second or two to load it, and once it's loaded, it's super fast locally. Everything is local. There's no traffic going back and forth to the server, and then when they're ready, they just save a button. They click the save button, and it all moves it up. So we've had like, again, and we have it in a few production systems, and it's been working really well.
Do you by chance have any like examples or demos, even if they're, you know, pretty vanilla, on, you know, how this works?
Yeah, we've been meaning to write it up and release some examples of it as a blog post or you know, just put it out there. The reason we just haven't is because we ended up discovering that we did want to do more of it through the data API, so we kind of paused for a moment. And then the other reason is we've just been so busy. It's just been really a time constraint to get it done. But our goal is to definitely put it out there and share it with the community. So that will be forthcoming. But I mean, you have the basic ingredients, right? It's pretty. We wanted to call it the Trojan horse technique, but I thought that was a bad idea. So, you know, basically it's a container, right? It's a container in this table, and this file is the local file, and this is exported on open, and this file has, you know, again, this is a trivial example, but if you look at you know, the other file, it may have a more complicated table structure. The local file might have just enough to get the work done. It may have a similar table structure, but just enough to get the user to make the changes that they need locally. And so, yeah, again, it's been evolving, and we've been moving more down the path of the data API and exploring what that has that can benefit us. So we'll definitely put this out there as soon as we can. But yeah.
This is Christy. I've got a question about, you had mentioned that the script on server could return an error if the record is locked. So what would happen with the data that you have in your queue? Would it not process? Would it go to your audit log as?
So like if we were to, let's see here, take this record and then take this record and make a change to it, or make a change to some of these dates, let's say, and then I save it, right? And if let's say this date is locked, or this record is locked, or whatever, using the data API, we would get alerted right away. So we would send it, and this would get packaged up in the format that the data API can consume, and then we would get a notification right away saying like, oh, you know. Depending on what we can capture, I can't remember now what we can capture in terms of errors, but it would tell us that, you know, your transaction didn't go in, and you would just get a dialogue right away. Otherwise, you know, save it and it goes in and it modifies it. So. So
does the audit log?
Pardon me?
So does the audit log keep track of what the requested change was? So if you had to go back and find what wasn't processed,
No, we don't put it in the audit log just because we haven't transacted it. So like if we add a date here, and then we change some other date over here, and we say save, and there was a lock on this record, this dialogue wouldn't go away. It would just stay here and say, hey, you know, I wasn't able to put your edits in. Do you want to try again? Do you want to cancel? So nothing went in. Nothing gets stored anywhere. So unfortunately, it's the same behavior as you would have in FileMaker right now. Other than, like, you know, if someone had locked this record and I tried to edit it, at the time that I tried to edit it, I would get a message saying, oh, you know, you can't make the change right now. You have to try again later because so-and-so locked the record. So yeah, but we don't log what we're intending to make the change. We would try and make the change immediately, and if it fails, then we notify the user immediately, and they can then take the appropriate action.
Okay, thanks.
All right. Any other questions?
Thanks a lot, Vince.
Thank you.
Yeah.
Yeah. You're very welcome. And I have noted that I would like to follow up on two things. So I will definitely do follow up as soon as I can on those two things. And it is our intent to put this out there so people can also have, you know, a look at it and comment on maybe improve it or whatnot. So definitely follow up on that. And yeah, check out our blog if you're so inclined to. There's some cool things on there, and again, thank you very much for allowing me the opportunity to present to your group.
Thank you.
Okay, bye everyone.
Thank you. Bye.
Thank you.
Bye.
Bye-bye.